Hey everyone, and welcome to this video on equations of lines. So let's make it happen. So at the end of the last chapter, we graphed all sorts of different equations and functions. Some of them were lines, some of them were U-shaped parabolas, and some of them were V-shaped. And there are so many different equations that we could graph, and they'll all look very different. But for right now, we're going to concentrate on just one type of graph, namely lines. So the first thing we want to do is to figure out what about the equation will make the graph look like a line. So here are four equations along with their graphs that are all lines. And let's look at their equations and see if there are any similarities between them that might help us predict that their graphs will be lines. Okay, now let's look at four different equations and their graphs, all of which aren't lines. And let's look at these four equations and compare them to the four that were lines and see if we can figure out anything that's different that might indicate why these guys will have graphs that aren't lines. One thing that I noticed is that in the four equations that didn't end up having lines for graphs, there was a variable in there with a power other than 1. And that wasn't the case for our equations whose graphs were lines. Every variable in there has no exponent or is raised to the first power. So the first thing we notice is in order for an equation to have a graph that is a line, no variable may be raised to any power other than 1. And for reasons we will discuss later, this actually includes any square roots or cube roots or any other roots. Okay, here are three more equations and their corresponding graphs, all of which of course are not lines either. Now, what about these equations might tell us that their graphs are not going to be lines when we compare them to the equations whose graphs were lines? Well, in these three equations, I see that there is a variable in the denominator of a fraction. And that certainly doesn't happen in any of our equations whose graphs were lines. And so, our second observation is, in order for an equation to have a graph that is a line, no variable may be in the denominator of a fraction. Okay, two more equations with their corresponding graphs, obviously not lines. Now, what about these equations might tell us that their graphs won't be lines? Well, to me, it appears that in these two equations, we've got variables being multiplied by one another. But in our equations that created lines, we had variables being multiplied by numbers, but never variables being multiplied by variables. And this brings us to our third observation, that in order for an equation to have a graph that is a line, there may not be any products of variables. Here are three last examples of equations whose graphs are obviously not lines. And when we compare these to the equations of graphs that were lines, we say, well, what's different about them? And in these three equations, I think there's just something kind of crazy going on. One has an absolute value, one's got a variable in the exponent, the other's got a variable in the exponent that's already in the denominator. So our last observation is just, in order for an equation to have a graph that is a line, in addition to the properties outlined before, the only elements that may be in the equation are just addition, subtraction, and multiplication between numbers and variables. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.